Welcome back, day 6 of this project, and today we're moving from research absorption to research action. Over the past few days, I've been diving into clinical studies and consensus statements on how researchers investigate SIBO and carbohydrate malabsorption. And now I'm beginning to design my own experimental model. The goal isn't to replicate a clinical lab, obviously, but it is to intelligently adapt methods from published research into something feasible, thoughtful, and data-driven, even at home. Just to center us, my working hypothesis is that high FODMAP carbs, like lactose or fructose, will lead to a greater rise in hydrogen gas in people with SIBO symptoms compared to low FODMAP carbs. That gas shows up in the breath, which is why breath testing is such a fascinating and accessible diagnostic tool. One article that's been central to shaping my understanding is a North American consensus on hydrogen and methane-based breath testing. It's not just a research paper, it's a clinical guideline written by 17 gastroenterology experts. Some highlights that really informed my thinking were there's still no gold standard for diagnosing SIBO, and breath tests come with limitations. For testing lactose and fructose malabsorption, a 3-hour window is essential to catch colonic fermentation. And for SIBO, a hydrogen rise of 20 parts per million by 90 minutes is considered clinically significant. Reading this gave me a clearer view of the nuances and the gaps in how breath tests are used. It also showed me where there's room to adapt. I also studied a few other key papers. One tested 25 grams of fructose, collecting breath tests every 15 to 20 minutes using gas chromatography. Another used 75 grams of glucose for SIBO detection, measuring both hydrogen and methane. Of course, those studies were done in clinical environments, controlled, expensive, and well-staffed. But the principles behind them, totally adaptable. The question I kept asking myself was, what matters most is the method, and how do I replicate the logic in a simplified but valid way? So here's where the adaptation really starts. I'll use foods and supplements I can control, lactose like milk, fructose like honey, and glucose tablets. I'll follow a strict prep day with a low FODMAP diet and an overnight fast. I'll collect time-stamped breath samples every 15 to 20 minutes for up to 3 hours. What I don't have is a clinical-grade gas chromatograph, but a simplified hydrogen breath monitor may be enough to detect trends. I also won't be measuring methane yet, but I'm keeping its potential effects in mind. The idea is to preserve the scientific thinking, even when you simplify the tools. So here's my early-stage experimental design. First off, I'll start with a low FODMAP prep day, as I mentioned previously. Then I'll fast overnight, and then I'll take a baseline breath sample in the morning. After that, I'll consume a test sugar like 25 grams of honey or lactose. And lastly, I'll log symptoms and collect breath samples at consistent intervals. I'll repeat this protocol with each sugar on separate days, essentially creating a small crossover study modeled after clinical research, but totally doable at home. Reading consensus statements and clinical studies gave me the scaffolding I needed. I now have a much clearer sense of what's essential, like timing, substrate dose, and breath gas interpretation, and what I can innovate on. In the next video, I'll walk you through the materials I'm gathering, the setup I'm building, and how I'm prepping for my first test day. Whether or not this ends up confirming my hypothesis, I already feel as though I've learned a lot just by engaging with the science at this level. So thanks for following along. If you've been enjoying this project or just love seeing what science looks like outside a lab, feel free to like, comment, or subscribe. I'll see you in the next one.